Welcome back. It's Professor Fleming here with 4.40 energy demand reduction. And last lectures we looked at energy from flows, renewable energy, etc. That was great, but that was really about supply of energy. Here we're going to be looking at energy, creating energy by saving energy, or energy efficiency, which is most associated with sustainable design of the built environment, which is primarily what this course is about. And certainly the second half of this course is going to be focused on that. Just as a review, from earlier in the semester, we talked about the Earth with a set of declining resources and an increasing demand for those same resources. We want to move to a restorative or regenerative future. In order to do that, we have to leap over the razor's edge, and no, I have not trademarked that term yet. But when we leap over that edge, we move to a situation where we can design systems that actually replenish the resources of Earth and also significantly decrease those demand for those same resources. And sustainable design is the lever by which that we do that. So that's just a brief review. We know that the world energy demand for energy continues to grow, and we know that's because not only because we have more people, but also because we have more affluence or wealthy people in countries around the world, and therefore energy demand is rising. Before I get into the Negawatt, I'm going to give you guys a short commercial just for some entertainment value. So just bear with me here.
Mr. Edison, today we lay to rest your creation, the incandescent light bulb. I know you're not shocked, sir. You knew that it needed an unreasonable amount of energy to do its job and that it had the lifespan of a lucky bug. Being as tireless as you were, you must have known that it would someday be improved upon and made obsolete. So that is why this is not a sad day. It is a celebration. The Cree LED bulb is a worthy successor. It lasts 25 times longer and uses a fraction of the energy of your invention. So it is time. Good night, sweet prince.
The Cree LED bulb, the biggest thing since the light bulb.
So the negawatt is a theoretical unit of power representing an amount of energy measured in watts saved. So for example, an LED bulb over an incandescent bulb would actually generate a fair amount of negawatts. This is the energy saved as a direct result of the energy conservation or increased energy efficiency. And it could be a light bulb, it could be a car, it could be a building, it could be a technology in a building. But certainly this is a big part of what we think of as part of sustainable design. This term was coined by Amory Lovins from the Rocky Mountain Institute, pretty well known, probably one of the leading thinkers in sustainable design. So the other major concept in addition to the negawatt is embodied energy. Embodied energy is not the kind of energy that we think of or see as a supply, but it's the total amount of energy needed to harvest, mine a material, process a material, transport a material, install a material, use a material, and eventually discard that material. So any building, for example, has a huge amount of embodied energy stored within it, or energy that has been spent to create that. If you think about the construction process, for example, all the machines that are used and all the transport that's used, you can imagine that there's a pretty heavy embodied energy footprint. So just as an example, aluminum is very high in embodied energy because of the heat needed to create the product, versus wood, which is a little bit lower in embodied energy, especially if the trees are grown locally. I'm going to be covering this more later in the semester. Just wanted to give you a little bit of a sense, but also thinking about, for example, historic preservation. Is that a way to save embodied energy of older structures, but also to save the cultural significance? So many people look at historic preservation as really early forms of modern day sustainability. Now, when you're advising a client on energy efficiency and you want to get the most negawatts generated from a decision by a client, the first one would be probably to not build. And there's certainly lots of reasons why people build, and there will be a lot of buildings, but if you can avoid construction at all, you're going to be saving a huge amount of energy. The second one would be to renovate, preserve, restore, repurpose. That was the historic preservation that I just mentioned. So rather than building new, for example, if you can take advantage of energy already spent in a building that exists, interior design, for example, is really an example of how we can preserve that energy. If we're going to build new, we're going to build new as small as possible. So one of the things that we're going to be talking about later in the second half is something called programming. Programming is where architects and designers actually figure out how much square footage is going to be needed to serve the client's needs. We'll see a lot of work in sustainable design around minimizing the program and sharing as many spaces as possible, or stacking those functions. So programming is really critical. If we're going to build new, we'd also like to build in a brownfield, which is a previously disturbed site. And that really has more to do with environmental reasons than energy reasons. And ideally we'd like to build an urban area to reduce the amount of transportation to and from home to building. Certainly building near public transportation can reduce the total carbon footprint of a building or a campus, and we'll be also getting into carbon footprint later in the second half of the semester or the season. And then finally we're going to try to build as highly efficiently as possible. And we use the term net zero energy ready because we can't guarantee that a building will be net zero energy depending on how the behavior of the occupants will go. So one of the frameworks that we use to think about how sustainable design is accomplished in order to have the maximum impact with the minimum cost, we use the green pyramid that we're going to show you here. Just because we did a lot of work on Maslow's hierarchy of needs, these pyramids have nothing to do with Maslow, so don't get too confused by that. So at the bottom of the pyramid, we look at the lowest cost intervention and have perhaps the highest impact. And here I've got the term intention, which is really the decision and or desire to build something that's highly sustainable or net zero energy. That intention is relatively relatively cheap to develop, but very and has a lot of impact through the process. So if you get a team of sustainable designers and builders and clients who all want to get a net zero energy building, you've got a really good chance of achieving that. If you have a client or an architect or an engineer only who want to do net zero, your chances are actually zero of achieving that. The next level up of intervention is really looking at behavior, how people use buildings. It seems inconsequential, but when you have buildings that have thousands of people in them who are operating lights and computers and all kinds of equipment, the amount of energy saved through behavior is really quite incredible, and we can use education and training to do that. Relatively inexpensive compared to, say, building a new building. And so the next level is actually building a new building. So buildings are actually static in the sense that they're not moving, and therefore you get a one-time shot at getting energy efficiency. So the orientation of the building, the location of windows, the disposition of spaces, all of those things which we're going to cover in the second half play a large role in the long-term energy efficiency of a project. And really it's only something that can be captured once. So we like to think that that's something that will obviously require more energy and more dollars. It's something that's pretty critical. At that point then we want to look at efficient technology. So the architect and designers and the entire design team have minimized the need for efficient technologies because that's really the most expensive investment that somebody could make. So we want to find and pay for the most efficient technologies possible, knowing that the long-term paybacks and energy savings are going to be worth it. And finally, at the very end, at the top of the pyramid, is where we see renewable energy technologies, which are really the most expensive investment that you can make as a client or as a sustainable designer. And so we want to really minimize the need through all of these other steps to generate a net zero energy building. So let's see how that plays out in a couple other frameworks and examples. So if we look at a building as a total, every building has a total building energy use is typical, can be very high for a code compliant building. So let's pretend we're starting with a code compliant building design and we want to get to net zero. What are some of the things we want to do? Well, we want to think about leaping over that razor's edge, if you remember, to get to, in this case, we're just going to get to the razor's edge at zero. So some of the ways we do that is we create a lot of negawatts through design and through education and through behavior change. We generate energy by not using energy. So again, the idea of intention and values at the start of the project, usually through an integrated design charrette, is the way that we begin to build a large negawatt process. And behaviors and actions, as I said before, are really critical. Passive design principles, efficient technologies all move that arrow towards zero, but it won't get you to zero. energy efficient appliances, for example. In this country we call those Energy Star appliances. All of those come together to create a huge amount of negawatts that then when we go to do renewable energy, which generates kilowatts, we're looking at a very small footprint or small investment in the renewable energy to get to zero. And that's really the formula by which architects, designers, engineers are all moving towards net zero. It's pretty exciting actually when you think about it. There's an example of how that plays out in the real world. This is the Bullitt Center by Miller Hull Architects in Seattle. It's a Living Building Challenge building, and it actually is reaching the net zero status. And the way they did it is very similar to the way we just showed. So for example, here's a typical baseline code building, and we're going to start here with intention. We're going to have an intention to get to net zero. So our thought processes and our consciousness and our determination and resolve are really critical in terms of driving things through, for example, the design process, where we begin through the basic design of the building to minimize energy. We're looking at technological uses like heating and cooling, for example. We can do that. We can have really high-tech lighting systems, for example, that can maximize daylight and minimize artificial lighting. And then for the tenant, we can have all kinds of behavior modifications. In this case, in the Bullitt Center, they built a beautiful stair that was so enticing that we would try to convince people to use a stair instead of the elevator. And finally, after all of that is done, we get to an EUI of 16, and I'll be explaining what EUI is next in the second half of the course. But basically it's a BTUs per square foot number, KBTUs per square foot number that gives us a way to compare different buildings. So 16 would be a very low number. And what that means is then when we go to PV or renewable technology, it's actually it's a much lower investment. And one of the things that we're going to be talking about later in the semester, I just want to go back for a minute. If you notice this roof, you see in order even to get to that small amount of renewable energy generated, this roof had to be very large. Now, of course, we're looking at stacking of functions, meaning that not only does this roof give more opportunities for PV, it actually creates a vast amount of shading on the facade, which in Seattle may not be the most desired outcome because it's a relatively cloudy scenario, but really you're looking at some additional energy savings there. So these are all pretty exciting ways to think about getting to net zero, and this really sets us up for the second half of the course for what I'm going to be calling week 5. I do have one more video on environment for you to watch, but I think we're getting very well set up and positioned for the second half of the course. So with that, I'll end this video, and I'll look forward to seeing you at the next video.